All right, we're going to go on P2 homework assignment, page 16. Hopefully this felt pretty straightforward for you. Number 24 and 26 wanted you to find the slope and y-intercept of these equations. Now, they weren't in standard y equal mx plus b form, which would have been super easy. You had to do a little bit of work. So like this one, you had to subtract 6x, which gives you 15 minus 6x, and then you had to divide by negative 5. So we end up with y equal negative 3, 15 divided by negative 5, and then a positive, because it's negative divided by negative, positive 6/5. Now you can make that 1.2, but I think with slopes it's just easier to leave them as fractions. So our slopes is 6/5. If you have 1.2, that's fine, and our y-intercept is negative 3. All right, so a little bit of algebra work, nothing too bad. This one, really no algebra, you just have to understand what you're looking at. Y equal negative 1, if you were to graph it, is a horizontal line at negative 1 on the y-axis. So the slope of a horizontal line is always 0. And the y-intercept, where did we hit the y-axis? Well, right there at negative 1. So again, easy as long as you understand what that is, right? And if you didn't, then you really didn't have anywhere to go. And that's a lot of calculus too. A lot of the AP test is a simple enough question as long as you understand what you're seeing and what you're doing. And if you don't understand, then there's really no chance for you. So we'll build those deep understandings in as the class goes on. Number 28 wants us to find an equation of a line that goes through this point with the slope undefined. So if the slope is undefined, that means what we're dealing with is negative 1, 2. We're dealing with a vertical line here. All right, that's what makes an undefined slope. And whenever we have a vertical line, it's always in the form x equal whatever the x value is. So for us, that would be x equal negative 1. So again, not too bad. This one here, same idea. We have to identify. I've got a slope of 0, and I'm going through 0, 4, which is right there. So that's a horizontal line, and horizontal lines always are in the form y equal, in this case, the value that we go through, which is 4. This one's the first one to use the slope or the point slope form, and we really want you using this. It's the easiest, it's the quickest, the way that gives you the answer without making silly mistakes. We want you going y minus y, so y minus the y coordinate equals slope times x minus the x coordinate. So x minus negative 2 would be x plus 2. We want you using that, and then don't worry. Like, you may have had a different teacher tell you you had to distribute and you had to get it into slope intercept. That's not true. You don't have to do those. Maybe there'll be a case where you need to because of it's being multiple choice and you need to get it to a different form, but 9 times out of 10, this is going to be good enough, and we want you to just get comfortable doing that. Okay. For 34, 36, and 40, we had to find the slope first. So we need to figure out how do we get from here to here, and that was a positive 3 change. And how did we get from here to here? Well, we went down 1, so our slope would be up 3, down, or left 1 would be a negative 3. Now again, I did change in y, change in x that way. Again, you may have had a different teacher tell you to go y2 minus y1 over x2 minus x1, and you would have gotten the exact same thing doing that. There's nothing wrong with that. I just like doing the actual physical change of y. How did I get from here to here and from here to here? All right, so our slope's negative 3. Now I need to make an equation. I have to pick one of these points. It does not matter which one I pick. I'm going to go ahead and pick that one because it's going to be the easiest. We get y minus 0, which is y, equals slope times x minus 0, which is x. Okay, so there's our equation. If you had picked the other one, it would be y minus 3 equals negative 3 times x plus 1, and that's perfectly fine too. And if you were to distribute this and add 3, you'd get the exact same equation there. So it's kind of nice that you don't have to worry about which point should I, but just pick whichever one seems easier to you. Same thing here. To get from negative 4 to positive 4, that's going up 8. To get from negative 3 to positive 1, that's going up 4. So my slope is 8 over 4, which is 2. I'll pick positive numbers over negative numbers, so I'm going to pick those there. Y minus 4 equals slope times x minus 1, and there's my equation. If you had picked the other one, you have y plus 4 equals 2 times x plus 3. There's nothing wrong with that. If you distribute this, then you end up with y equal 2x and I believe plus 2. All three of these equations are legit. One is not better than the other. Any of them would work. Okay, and the AP understands that. That's how they grade it too. If they ask you for an equation of a, they'll say an equation of a tangent line. We'll learn how to do that in chapter 2. Any of these would work. All right, same thing here. -2 to -2 has no change, so 0 there. From 1 to 3 is up 2, so our slope is 0 divided by 2, which is 0. That means we're dealing with a horizontal line. So right away, because we're dealing with a horizontal line, I could just simply kind of think about it like that. 1, -2 is right there. My horizontal line goes like that. Okay, so this must be y equal -2. But if you were to use the point slope form, that's fine too. You could go y minus -2 equals slope times x minus 1. And technically that works. 0 times this would be 0, so you get y plus 2 equals 0, and you end up with same thing, right? So it doesn't matter. You can get there one of two ways. It's good to have, again, that understanding piece. Don't just get locked into a method. Well, I have to do these steps every time in order to do the problem. We want to get out of that in calculus. We want you to have a bigger picture idea of what's happening around you and being able to kind of pick the right tool for the right problem. All right, 69 here wants us to find the points of intersection. We can use our calculator to do that. So we're going to take our calculator here, and we're going to go ahead and put these in. So we have just plain old x squared for one of them, and for the other one we're going to have 4x minus x squared. Okay, I'm going to go to a regular window, zoom 6. There's my x squared, and then there's my 4x minus x squared. So calculate intersect. First curve, that looks like 0, 0, and sure enough, that's my intersection there. So one point of intersection is 0, 0. The other one looks like it might be like 2, 4. That's kind of a guess, but let me make sure. So if I get kind of close up to there, sure enough, 2, 4 is that other one. Okay. Now what they wanted us to do then was to find an equation, and then once we have an equation, put it in and actually see it go through that. So we'll go ahead and do that here. My slope for this line between these 2 points would be up 4 and over 2. So I get a slope of 2 for that. And if I pick this equation, or this point, I get y minus 0. So y equals 2 times x minus 0, x. I end up with y equal to 2x as my equation. So now I want to do that. I'm going to go y, and with these two, I'm going to type in the line y equal 2x. I want to see it go right through them. And you can kind of see it. It doesn't look very spectacular because everything's so blown up. So maybe let's change our window. Now, we can, hopefully you're good at going to the window and making it what you need it to be. I want to show you something that you can do as well. It's called a zoom box, very first option. And what that allows you to do is to draw a box around the part of the graph that you want to see. So I'm going to start a corner right here for the box. I'm going to hit enter, and then I'm going to scroll up, and then I'm going to scroll over. And you can see that it's putting a box around the part of the graph that I'm interested in. When I hit enter, now it'll just blow that up for you to see. So I hit enter, and there's now just the piece that I was interested in. And there's the two intersections, and there's our line connecting from here to here, splitting it in half. All right. So just another little trick. How often would you use it? I don't know, but it's there for you if you need. All right. All right. Then our last one here gave us a gym, or it was a deal where you got paid $150 a day, plus you had to pay 34 cents per mile, and they wanted you to come up with an equation for the cost of this. So our cost will be $150. Now, you might have been tempted to put a D here for day, and I wouldn't have blamed you for that, but we're going to assume they're talking about the cost per day, so we don't need that D in there. We're just assuming for one day, what's the cost? It's $150 plus 34 cents per mile. So if you threw a third variable D in there, don't beat yourself up, but you didn't need it for this problem. If you wanted to get fancy and put this in function notation, you could have put this as the cost per mile, the cost based on the number of miles is this. And then our cost for 137 miles would be 150 plus 34 cents times 137. So we'll just do that real quick. 150 plus 34 times 137 gives us $196.58. So again, hopefully this feels comfortable, and if there's been a while for some of these things, or maybe you don't remember quite, it makes sense to you, and you did okay.